Hi, in this video, Mr. Tan going to teach you how to find the fourth roots of this complex number here. So to finding the fourth roots of this complex number, at first I want to apply the n roots method. In order to apply the n roots method, I have to rewrite this in polar form. So at first I have to show you, you can rewrite this in polar form. As I already doing a video for how to convert a complex number into a polar form, right? So into a polar form. So you can refer to the video before you trying to looking what I'm going to do in this video. I'm going to find the roots, the fourth roots of this complex number, right? So first you have to have the prior knowledge about how to convert the complex number into polar form. So for here, I just show you some. So 8, I factorize the 8, 1 minus square root of 3i, right? So I can convert this into a polar form, alright? Means that you can write this in a polar form, r cos theta plus with I sin theta. This is what I mean here. So I sin theta. So what to do? You have to find the modulus for this. As the modulus for this, you were giving you 8. The modulus will be 2, alright? For this a square plus b square square root, so you are getting 2 here, and for this you are getting cos. Cos, as the argument for this will be negative pi over 3, right? Okay, negative pi over 3. So negative pi over 3. The argument is negative pi over 3. So you have to watch the video about how to convert the complex number into the complex number into polar form, right? Before you looking at this video. So cos negative pi over 3 plus with I sin negative pi over 3. The argument will be negative pi over 3. So this will be the polar form for this complex number. Okay, I rewrite 8 square root of 3i. 8 times 2, you have 16, right? 16. So 16 cos negative pi over 3, negative pi over 3 plus with I sin negative pi over 3. So I repeat again, this will be the polar form for this complex number, alright? For this complex number. So now I'm going to find the fourth roots of this, right? The fourth roots of this by apply the n roots method. So what is n roots method? So I have to show you the n roots method, which the z power of 4. So find the fourth roots of 8 minus of this complex number is the same as the finding the solution for z power 4 equals to 8 minus 8 square root of 3. So I repeat again, to find the fourth roots of this complex number is the same as finding the roots, finding the solution for this equation, right? Z power 4. If there are cube roots, here will be z power 3. Fifth roots, it will be power 3. Okay, so then now I have this complex number, and I have to rewrite this in order to using the n roots method. I have to rewrite this in polar form. Okay, so the n roots method will be something like this. So 16, just adding the cos, just adding the argument with a 2 pi k. The method here is you adding with something here. So plus with I sin negative pi over 3 plus with 2 pi k. So the most important part here will be, here you were having a 2 pi k if you want to apply the n roots method. So because I want to find the fourth roots of z, so the fourth, I try to fourth roots for this both side, which were giving me z equals to the fourth roots of 4, 16 to the power 104. You were getting 2. You were getting 2, as 2 to the power 4 is 16. So whereas here you have cos So negative pi over 3 plus with 2 pi k. It's the same thing here, right? It's the same thing for this, just adding a 2 pi k into the argument. Okay, into the argument. So 16 negative pi over 3, just adding a 2 pi k. So before you finding the fourth roots of 8 minus 8 square root of 3i, this complex number, so plus with I sine negative pi over 3 plus with 2 pi k. Then the 104, 16 to the power 104, here will be also power of 104, right? Power 104. So 16 power 104 is 2, and this whole thing also power of 1 over 4. So in order to simplify this, I have to apply the Moirer's theorem, right? The Moirer's theorem. So you can refer to the video where I talk about the Moirer's theorem. So z equals to 2 cos, and the Moirer's theorem, this will be power of n, the n multiplied into the theta, so which will be 1 over 4 multiplied with negative pi over 3 plus with 2 pi k, plus with 2 pi k plus with I sine 1 over 4 negative pi over 3 plus with 2 pi k. So this, applying the De Moirer's theorem, I already write in this form. Okay, multiply with the 1 over 4 here. Can you see that? The 1 over 4 I have already multiplied into the argument. So I'm going to apply the n roots method, where if I want to find the fourth roots, then the k values we know that there will be a 4 roots, okay, 4 fourth roots of this. So what I do will be, they have to be 0, 1, 2, and end with 3. If they have a power of 4, it will end with 3. If power of 3, it will end with 2, but always start with 0. If they have a power of 5, it will be end with 4. So means that if there is power 5, it will be 0, 1, 2, 3, 4. Alright. So now it's 4, so we start with 0 up to 3. So now I'm using this 4 number to finding the different value of z. So which we will have 4 different value of z. So first, the easier way to writing all the solution is you just assume this, you just letting this to be your theta. Okay, your theta will be equals to 1 over 4 negative pi over 3 plus with 2 pi k. So with k is 0, 1, 2, and 3. So start from now, I'm going to list all the solution here. So for z1, for first, when k equals to 0, so what is your theta, right? When k is 0, you substitute into here 0. So the first theta will be 1 over 4 negative pi over 3 plus with k is 0. So 0, so you are getting negative pi over 12. So this will be the first theta. Now, finding the second theta. Alright, so you have 4 different theta because you have 0, 1, 2, and 3. So when k equals to 1, so your theta will be, by using this formula coming from here, so will be 1 over 4 negative pi over 3 plus with 2 pi k, which k now is 1. So 2 pi times 1, you have 2 pi. So you are getting negative pi over 3 plus with 2 pi, which is 6 over 3. 6 minus 5. 6 minus 5. So you are getting here, after simplify, you are getting 5 pi over 3, right? 5 pi over 3, this whole thing is 5 pi over 3 multiplied with 1/4, you're getting with 5 pi over 12. 5 pi over 12 as the second theta. So now we're finding the third theta when k equals to 2, right? So when k equals to 2, substitute here 2, you're getting 4 pi. 2 pi times 2, 4 pi. So which is theta equals to 1/4 negative pi over 3 plus with 4 pi. So 12 over 3. 12 over 3 minus with 1/3. So 11 over 3 multiplied with 1/4. So 11 over 12 pi. So this will be your third theta. 11 pi over 12. So now go for the last one. K equals to 3. So your theta will be 1/4 negative pi over 3 plus with 2 pi k, right? 2 pi k. So k equals to 3. 3 times 2, 6 pi. So you're getting 6 pi here. So your fourth theta will be negative 18 minus 1, 17 over 3. 7 over 3 plus 1/4 times 1/4 will be 17 pi over 12. So now you have 4 different values of theta. So you have 4 different negative pi over 12, 5 pi over 12, 11 pi over 12, 17 pi over 12. So these 4 different values of theta will produce 4 different roots. Alright, 4 different roots for this complex number. So means that I just substitute inside here this whole thing, the theta. So the first one, the z1 will be when the theta is negative pi over 12. So 2, as here you have modulus 2 cos negative pi over 12. Negative pi over 12 plus with I sine negative pi over 12. Negative pi over 12. So your z2 will become from the theta when k is 1, right? So which is 5 pi over 12. So same thing, repeat, 2 cos plus with I sine, just the argument here become 5 pi over 12. So 5 pi over 12. So this will be the second solution. The third solution will be 2 cos plus with I sine, and here will be 11 pi over 12. Pi over 12. So now you have 3 roots. So another root will be 2 cos 17 pi over 12 plus with I sine 17 pi over 12. So this will be the roots. Okay, I can rewrite this as z equals to the set of z1, z2, z3 and z4. So means that I want you to copy all this in the set form to tell you that there is a solution for is the roots. Okay, it's the fourth roots. The 4 got 4 fourth roots, 4 different roots for this, because it's the fourth roots of this, right? So you will have 4 different roots. So then because of this will be it's not a special angle, means that this is not something like 30 degree, 45 degree, 60 degree, 90 degree, right? It's not a very special angle. So I just rewrite my solution, the roots in polar form, right? Just leave it in this form, in polar form. So then this will be your answer for this, your roots for this for the fourth roots of this complex number. Alright, that's all for this video. And one more, okay, sorry, I have to telling you that because there is a fourth roots, so there is a 4 roots, so we will try to look at actually the difference between this. The difference between these two angles will be you taking 2 pi, or we said 360, one cycle, divided by 4. Alright, divided by 4. So means the difference between the two subsequent argument will be pi over 2. Right, you can try it. You can taking negative pi over 12 plus with pi over 2. Shift pi over 2. You are getting 5 pi over 12. Right? So now you're adding the 5 pi over 12 again with shift pi or the pi over 2. So you are getting 11 pi over 12. Right? And you're adding again pi over 2. Sorry, pi over 2. Pi over 2. You are getting 17 pi over 12. So this is also to tell you that the difference between this argument will always be pi over 2. Okay, how you know that? You can just taking the 360, okay, or we said in radian is 2 pi divided by 4, because they have 4 roots, then divide by 4. If there is 5 roots, then we divide by 5. If let's say it's 3 roots, because cube roots, so you divide by 3. Alright, so then you can know that the difference is the number here. Alright, so that's all for this video.